Okay, moving on to 6.3. I want to talk to you about the key features of a quadratic. Now, you don't know any of this. This is all brand new. So relax. Let's just go over it. Let's see what's here. So, the first thing, there's this thing called a vertex. We're going to have to learn all of this vocabulary. There's a thing called a vertex, and the vertex is the point at which the parabola changes direction. So where it changes from increasing to decreasing or decreasing to increasing. Let's just stop for a minute and look at these three examples that I have down here. Here's a parabola. Here's another parabola. And here's a third parabola. Now remember, we always read graphs from left to right. So as I go left to right in this direction, notice what's happening to my y values. They're coming down, 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 until they stop here. And what's the very lowest point they stop at? They stop at a y value of -1. That's the lowest value they stop at. And then notice what happens. They go up, 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 up. So there's a couple of things I need to discuss with you here. As we move from left to right, and if the y values are coming down, 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 moving left to right, this is called decreasing. So this curve is decreasing all the way up to 3. And then from 3 on, the y values start going up, 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 up. This is increasing. And I don't think that's a hard concept. It's decreasing as I come this way from left to right, and I'm increasing as I go that way. Does that make sense to everyone? Just looking out into the audience. Okay. And where does it change from decreasing to increasing? It's changing right here at this point. Would you agree? It's changing right there. And that point is 3, -1. Well, that by definition, people, is what we call the vertex. That point where it changes direction is what we call the vertex. So this is the vertex. The vertex for this parabola is 3, -1. That's the vertex. That's where it changes direction. Make sure you're with me, Sean, because it gets really bad if you don't know what this stuff means and you're trying to do it. All right, look at this graph. I'm coming up, 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 up. I stop, and then I come down, 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 down. So what's happening? I'm increasing on this side, aren't I? This is increasing. And then I'm decreasing on this side. And right in the middle is a spot where I change direction. Well, that spot is called the vertex. It's a special name. Learn how to spell it. And that vertex on this parabola is at 2, 1. So 2, 1 is the vertex on this parabola. Okay, not bad. Let's look at this one. So, as I move left to right, I'm coming down, 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 down until I hit here. And then I'm going up, 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 forever and ever and ever more. So as I'm coming down, we call that decreasing. Fair enough? And when I'm going up, we call that increasing. Now, here's a short form for the word decreasing. An arrow going straight down, decreasing. Fair enough? And over here, an arrow going up, increasing. Fair enough? This point is where it changes from decreasing to increasing. It's where it changes direction. What do we call it? Vertex. That's right, it's got a special name. And its coordinates on this one are 0, 4. There you go, guys. You just learned what a vertex is on a parabola. It's where it changes direction. Okay? Now, what about a maximum or minimum? Yeah, Fernando?
Can there be more than one vertex?
Ooh, if there was more than one vertex, then I guess what would be happening is you would be coming down, 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 going up, and then you'd have to come down again. And that is not a U shape, is it? That's not a U shape at all. A parabola either looks like this, it's a U shape like that, or like that. This is not a parabola. Therefore, it's not a quadratic. So the answer to your question is no, a quadratic can only have one vertex. Can we get a graph that looks like this? Absolutely. It's just not a parabola. Okay? Maximum and minimum values. The maximum is the greatest y value on the graph. And the minimum is the smallest or the largest negative y value. In other words, it's the one lowest on the graph. So the minimum is the lowest y value, and the maximum will be a highest possible value. Now we got to be careful here. Take a look at this parabola. It goes down, 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 and then it goes up, 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 up. There is no maximum. Let's get this very, very clear. See this? See those arrows? They keep going and going and going. There's no maximum point. None. However, is there a minimum point? Is there a smallest y value we can have? Yeah, it's right here. So this is a minimum. So this vertex is a minimum vertex. What about this vertex? So it goes up, 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 and it hits a top, and then it must be below that. So this vertex is a maximum vertex. Do you see the difference? A maximum vertex is where we get to a top and everything else is below. And a minimum vertex is where we get to the bottom and then everything else is above. So what would this be? A maximum or a minimum? It's a minimum. Come down, 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 hit a minimum, then up, 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 up. What is the value of the minimum? Well, in this case, the value of the minimum is -1. That's the lowest y value. In this case, what's the value of the maximum? +1. And in this case, what's the value of the maximum? Are we good with that? Okay. Next. There's something called an axis of symmetry. Now the axis of symmetry is the line. It's a vertical line. So if it's a vertical line, it has the equation x equals, right? So it's a vertical line that passes through the vertex. So let's look at this one. The vertical line that passes through this vertex is right here. That's the vertical line that passes right through that vertex. And that has an equation of x equals 3. And notice it's the same value as the x value in the vertex because it passes through the vertex. That just kind of makes a lot of sense once you know what you're doing. Here's my axis of symmetry on the next one. It passes right through the vertex, which means it has the equation x equals 2. Notice it cuts the parabola in half. One side is symmetrical to the other side. If this was a mirror, and if I was to reflect it, you'd see it would line up perfectly, wouldn't you? That's why it's called an axis of symmetry. What's on this side is symmetrical to what's on this side. And this one, where's the axis of symmetry? Well, it's right down here. And its equation is x equals 0. So notice that all of the parabolas have an axis of symmetry. They have different equations. X equals 3, x equals 2, x equals 0. Notice that they're all x equals because they're vertical lines. And notice that this value is the same as the coordinates of the vertex value. What about the y-intercept? Where does each one cross the y-intercept? Well, to do that, you sort of have to look at the equation or look at the graph. This seems to have a y-intercept right here. So that y-intercept is 8. It crosses at 0, 8. So when x equals 0, the y value is 8. And then the next one, you sort of have to look at it, and I can see it here. So it has a y-intercept of -3, which means that it crosses at 0, -3. So when x is 0, y is -3. And the last one, where's the y-intercept? Well, that's kind of neat. It's at the vertex. The vertex is actually where it crosses the y-intercept. So this is at 0, which means that it crosses at 0, 0. So that is the y-intercept. What about x-intercepts? X-intercepts are where it crosses the x-axis. Here's one. Here's another one. There's 2 x-intercepts for this one. One of them is 2, and the other one is 4, which means they cross at 2, 0 and 4, 0. Because remember, for an x-intercept, your y value equals 0. What about the next one? I've got 2 x-intercepts for that one. They are x equals 1 and 3. So it crosses at 1, 0 and 3, 0. So this one has 2 x-intercepts. This one has 2 x-intercepts. And this one has no x-intercepts. Because the vertex is above the x-axis and it opens up. The vertex is above the x-axis and opens up. So there are no x-intercepts. Here's my x-axis. Everything's above the x-axis. It doesn't cross the x-axis. There are no x-intercepts. So the last thing I really want to draw your attention to, on this sheet anyway, is that how do we know when it opens up or down? Because that seems important, doesn't it? If some of the parabolas open up and some of the parabolas open down, how do we know? Well, the answer's right here. If the number in front of the square term is positive, if the number in front of the square term, so what I'm talking about the square term is this, ax squared, we're talking about the a value. So if the a value is positive, it opens up. And if it opens up, take your finger and go like this. If it opens up, then it's going to have a minimum. And if the A value is negative, then it opens down. And if it opens down, take your finger, if it opens down, I get a maximum, a top of the hill. So you're going to have to keep that straight. So if it is positive, if this A value is positive, I'll give you an example of a positive A. How about 3x squared? That has a positive A, so it's going to open up, and if it opens up, it's got a minimum. And I'll give you an example of a negative number. How about negative 3x squared? Well, that's going to have a negative A, so it opens down, and if it opens down, look what you got there. You got a hill. So that's a highest point. That's a maximum. Now, ladies and gentlemen, this is all new. You've never seen this before. You're going to have to shut this video down and watch it again and relearn each of these words. Very important. I'm going to stop there and we'll be right back.